Hello, algebra students. Mr. Lawrence here, and here is your summer packet review video. Hopefully you've finished your summer packets by now. Some of you haven't. I gave you till Monday. Get them in. I'm just going to talk about a few problems in the section. Remember, honors algebra, you're having a quiz over this on Tuesday, and regular algebra, you're having a quiz over this on Wednesday. All right. Now, I'm not going to say much about section 1, the next 3 numbers. Usually you guys can figure this out. But I was really impressed. I can't remember who it was, but it was a girl. She wrote at the bottom of problems 5 and 6 actual patterns using a variable. And that is very intelligent. And I'm going to teach you how to do that because it's not good enough to just be able to say, well, I know the next number is blank. I wanted to create a formula that will be able to tell me any term in the sequence. Maybe I want to know the 150th term. Okay, but so I'm not going to do this problem. I expect you to know how to do this part already, but later on I will teach you how to find the what we call the nth term. And some of you were asking about the stacking rings, the Fisher-Price stacking rings in the room. We're going to do that when we work with those. Okay, so let's get down to section 2. Most of you nailed this stuff, but some of you didn't seem to know what this was. Your quadrants are the 4 sections of the graph that are created by the x and y axis. This is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4. And this should be peer review. If it's not, you need to come in and see me quick. All right, now it's important to know that in quadrant 1, the x-coordinate, which always comes first, is positive. The y-coordinate is also positive. In the second quadrant, x is negative. The y-coordinate is positive. The third quadrant, they're both negative. And in the fourth quadrant, they are positive x and negative y. Believe it or not, some people were really messing that kind of stuff up. So if I have to take this point, negative 3, 5, I'm on the x-axis. I'm going to go negative 3. In other words, I'm going to go to the left. 1, 2, 3. And then I'm going to go positive in the y direction. 1, 2, 3, 4, 5. You should never get the x and y screwed up because they're alphabetical. X comes before y in the alphabet, so the number that comes first is the x coordinate. By the way, that is in quadrant 2. Okay. Now the other one, 5, negative 3, I'm going to go positive 5 in the x direction. 1, 2, 3, 4, 5. And then down 3 in the y direction. 1, 2, 3. And there we are. That's the point 5, negative 3. And that is in quadrant 4. Okay, if you're not sure about how to do this or you make mistakes with it, you got to come in and see me. I expect you to know it already. Graphing. Now, overall, most of you did the t-chart fine or the table fine, but then you made mistakes along the way. So I'm going to go ahead and I'm going to put 1 in. A lot of you put 1 in. 5 times 1 is 5. Minus 1 is 4. Well, that means the point 1, 4 is on my graph. So I'm going to go 1, 1, 2, 3, 4 in quadrant 1. Now some of you went ahead and put 2 in. Okay, 2 times 5 is 10, minus 1 is 9. So 2, 9 is going to be on the graph. Okay, so what do you got? 1, 4. Now 2, 9. Now a lot of you put 3 in. And I don't understand why you would put 3 in. Because 3 times 5 is 15. And 15 minus 1 is 14. And that ends up being off the graph. A messy situation. Why not pick a different number? Something easier. Maybe 0. I saw almost nobody pick 0 for their x-coordinate. 0 makes the math simple. 5 times 0, 0. Minus 1, negative 1. So 0, negative 1 is on the graph. Now you were asked to draw the line. Well, a lot of you, and I don't blame you for this because the worksheet looks like it. You did that. Okay. That is not a line. That is a line segment. For it to be a line, you have to make it go forever. Go through the points, and then you put arrowheads on your line. Okay? Take up a lot of the graph. That is a properly drawn line. It's perfectly straight. Use a straight edge to draw your lines, please. Put arrowheads on it. Don't stop at the 2 endpoints. Those 3 numbers, 3 sets of points, 0, -1, 1, 4, and 2, 9 are not the only three solutions. There are an infinite number of solutions, and they're all shown by this line. Any point, if you know the coordinates, if you plug it into this equation, you'll get a true statement. Watch this. I'm going to plug 0, -1 in. Y is -1. 5 times 0. Is that true? 5 times 0 is 0 minus 1. -1 equal -1. Yep, it's true. Any ordered pair that you know is on this, the coordinates of will be on this line. Okay, if it's on this line, it'll be a solution to this equation. Excuse me, I said that wrong. Remember, you don't have to pick 1, 2, 3. Sometimes it's a very poor choice. All right. Oh, by the way, how do you tell if it's linear? Does it make a line? Does it make a line? If it makes a line, then it is linear. Yeah, linear means in a line. Okay, order of operations. Remember, we're not going to use PEMDAS. I know the packet referred to PEMDAS. I don't use PEMDAS at all. Kids make mistakes with it. I'm not doing it. So we know that in order of operations, we have to do the parentheses first. But unfortunately, in the parentheses, there's nothing to do. Inside the parentheses, there is. So I'm going to go to my exponents, and I have to do 3 to the second power, and my airliner just shut off. Uh-oh. There we go. Seems to have fixed the problem. So I'm going to do 3 squared. And while I'm at it, I can do this 4 squared too. So I'm going to get 16 times 2 plus quantity of 7 minus the quantity of 9 minus 4. Now, order of operations says to keep working in the parentheses. Get those parentheses simplified. So 16 times 2 plus quantity of 7 minus 5. That means I have 16 times 2 plus these brackets count as parentheses. So I'll have 2. Now, according to our operations, I have to do multiplication. I'll get 32 plus 2, which is 34. And there you go. That is correctly solved. Problem 13, order of operations. I'm going to do 4 minus 7. I'm going to get -3. And then I'm going to have -3 times -3, which is going to be +9. I expect you as algebra students to know that 2 negatives multiplied make a positive. All right. By the way, you see this kind of problem a lot on the internet, like on Facebook or something. Okay. The answer to this problem is not 9. You have to do the order of operations first, which says to do multiplication. And so you can see the answer to this is -1. If you're weak on that, come get some help before it matters. All right. Add fractions. To add fractions or subtract them, we have to have a common denominator. I like to count by the larger of the two denominators until I get a number that the smaller denominator goes into. So, 5, 10, 15. Whoop, 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 whoop. 3 goes into 15. My magic denominator is 15, or my common denominator, I should say. So my problem is 3/5. And I don't like this plus a negative. That's the same thing as a minus. 2/3. If you don't understand that, come see me. I'd love to explain it to you. And I've got to turn this 5 into a 15. Well, I'm going to multiply it by a 3. If I do it to the denominator, I'm going to have to multiply the numerator by 3. And so my new fraction on the left becomes 9/15. Now, I'm going to multiply this guy by a 5. Why? To turn the denominator into 15. But to do it to the denominator,
Ms. Kuhar, if you're in the building, please call the office.
I'll have to multiply the numerator by 5. So then I have minus 10/15. 9 minus 10, I have 9/15. Take away 10/15, that would leave me with a -1/15. And there you go. Now division and multiplication with fractions is a little bit easier. I do have to remember that dividing by a fraction is the same as multiplying by the reciprocal. We'll talk a little bit about why that's true later. And I like to simplify first. I think it's foolish to multiply and then simplify. And when I simplify, I know I can look this way, this way, this way, and this way. So I'm going to look. Does 4/5 simplify? No. Does 10/3 simplify? No, it doesn't. Does 4/3 simplify? No, it does not. Does 10/5 simplify? You bet your boots it does. I'm going to simplify this because I can think about this problem, 4/5 times 10/3, as 4 times 10 over 5 times 3, right? Which is the same as 10 times 4 over 5 times 3, which is also the same as 10/5 times 4/3. So you see, I can simplify diagonally because of what I just did. And I can think about 10/5 as 5 times 2 over 5. And those 5's would cancel out, turning this part into a 2. 4 times 2 is 8. Denominator 1 times 3, 3 8/3 is my answer. If you don't like fractions, I don't want you to run to a decimal. For somebody that did all the fraction problems as decimals, just use the calculator, you know you got no credit for that part of the packet. You were expected to do the fractions. The notes above showed you how to do it. You ran to a calculator. I cannot reward that. If you need some help, please come in and see me and I'll show you how to do it. All right, if I want to turn it into a mixed number, I can say 3 goes into 8 2 times. It's too short. 6 is too short of 8, so there's 2 left over. And I divide it by 3, 2 and 2/3. Either answer is acceptable. All right, video's getting a little bit long here, so I'm going to wrap it up. I'm going to look inside the parentheses. There's nothing I can do, so I'm going to distribute. Now, you may not know this part, but 3 times -5 is -15. You may not know what x times x is. Well, for right now, it's x squared, and we'll talk about why it is later. Okay, then I do 3 times -4 and get -12, and then there's an x along for the ride. I can't put those together because they're not like terms. Number 30, I can think about this problem as two fractions, 36y over 12 minus 30 over 12, and then simplify both fractions. The first fraction will turn into 3y, and the second fraction will turn into, oh, that shouldn't be a equals, I'm sorry, it should be a minus 5 over 2. I'm totally okay with that answer. If you want to go like this, I won't get upset. Please read it right. That's 2 and 5/10, not 2.5. Or if you want to go like this, keep writing equals, excuse me, 2.5. I really don't like those. I like this one better, but these are mathematically correct and we'll get full credit. All right, I think that there are two more problems here, and they look similar because they have more than one variable, but there's a difference. On this left-hand side one, I have like terms that I can put together. So let me find my highlighters here, and I've got a -4x and a -2x. Those are like terms. That means I have -6x's. There's a 4 that I didn't do anything with, and then a -5. And now it looks like a simple two-step equation. I'll subtract 4 from both sides. -6x is equal to -9. I'll divide both sides by -6. And x will equal 3 over 2 if I simplify, or 1.5. The problem 14, I have to distribute first, and I'll get 2x plus 2. That'll equal 3x minus 3. Now, the x's are not on the same side of the equal sign, so therefore, I cannot combine them. I can't combine like terms through an equal sign. I don't like that there's x's on both sides, so I'm going to take away. Remember, subtract means to take away one of the x terms. And when I do that, the left-hand side is going to turn into 2. The right-hand side is going to turn into x minus 3. And then I'm going to add 3 to both sides. And so I'm going to get 5 equals x. And there you go. All right, that's it for the video. Remember, your quizzes are Tuesday or Wednesday, depending if you're in honors or in level two. Have a good night, everybody.